Going to do Patient Edexcel International Advanced Level Maths paper for paper 2. This is pure maths 2. This is the other variant for pure 2 and this is for May 2024. If you want to check out the other variant, you can check it at the link above because I've already posted that. So let's start with this one and see how difficult or easy paper 2 was. So it says the sequence U1, U2, U3 satisfies UN plus 2 equals to 3 times UN plus 1 minus 2 UN. Given that U1 is 7, U3 is 4, we have to find the value of U2. So let's say we say n equals to 1. So if n equals to 1, it's going to be U3 equals to 3 times U2 minus 2 times U1. So we know that U3 is 4, U2 is what we're trying to find, and U1 is 7. So 4 plus 14 equals to 3 U2. 18 equals to 3 U2. And 6 is U2. So that's the second term. Then find the sum of UR plus 2R from R equals to 1 to R equals to 4. So we know UN is given as UR plus 2R. So when you put R equals to 1, it's going to be U1 plus 2. R equals to is going to be U2 plus 4. R equals to 3 is going to be U3 plus 6. R equals to 4 is going to be U4 plus 8. So that's basically U1 plus U2 plus U3 plus U4 plus 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. Now for U1, U2, U3, U4, we already know that U1 is 7, U2 is 6, U3 is 4. So U4 is going to be U4 equals to 3 times U3 minus 2 U2. So that's going to be 3 times 4 minus 2 times 6, which equals to 0. So over here, U1 is replaced by 7, U2 is replaced by 6, U3 is 4, and U4 is 0. Add it up, and that gives you a value of 37. That's your answer. Then since the table shows corresponding values of x and y for a continuous curve with equation y equals to f of x between x equals to -4 and x equals to 5, where a is a constant. The trapezium rule is used with all the y values in the table to find an approximation for f of x starting from -4 to 5. Given that the value of this approximation is 19.3, find the value of the constant a to 3 significant figures. So for that, what we do is we create an equation where 19.3 equals h over 2. So h is going to be the difference between any two consecutive numbers. So if I do 2 minus 0.5, that's 1.5. So 1.5 over 2 times. For that, we use the first value, add it to the last value, and then we do plus 2 times all the middle values. So it's going to be just like that. 4.16 plus 2.28. 4.16 is the first value, 2.28 is the last value, plus 2 times the middle values. So that's going to be 2.91 plus a, then plus 1.73, then plus 1.37, and then plus 1.43. And that's going to be 19.3 equals to 0.75 times 6.44 plus 2 times 7.44 plus A. That's going to be 19.3 divided by 0.75, and that equals to 6.44 plus 14.88 plus 2A. Then that's 25.73 equals to 21.32 plus 2A, which is 25.73 minus 21.32 divided by 2, and that gives us a value of 2.205. They want the answer correct to three significant figures. So three significant figures are going to be 2.218. That's your answer. Then use the given answer of 19.3 to find an approximate value for the integral of 2f(x) minus 3 from -4 to 5. So for that, what we will do is -4 to 5, and it's 2f(x) minus 3 dx. Let's separate this. So from -4 to 5, it's 2f(x) dx minus -4 to 5, 3 dx. 3 outside, -4 to 5 fx dx minus 3 -4 to 5 dx. Now we know the integral of f of x from -4 to 5, which is 19.3. This is 2, sorry, not 3. So that's going to be 2 times 19.3. And we know integral of dx or a constant is just x. So 3 times x, limit is -4 to 5. So 2 times 19.3 is 38.6 minus 3 times 5 minus -4. That's going to give us a value of 11.6. That's your answer. Then since the circle has equation x squared plus y squared plus 8x minus 14y minus 79 equals to 0. Find the coordinates of the center of the circle, then the radius of the circle. So for that we have to convert this equation into completing square form. So we'll do completing square form separately on x and separately on y. So it's going to be x squared plus 8x, then plus y squared minus 14y equals to 79. So we apply completing square on this and then on this, basically. So it's going to be x squared plus 8x plus 4 square minus 4 square. And for y, it's going to be plus 7 square minus 7 square. This equals to 79. So that's going to be x plus 4 whole square minus 16 plus y minus 7 whole square minus 49 equals to 79. That's going to be x plus 4 whole squared plus y minus 7 whole square equals to 79 plus 49 plus 16. X plus 4 whole square plus y minus 7 whole square equals to 144. So your coordinates of the center are -4 and 7. And then your radius is going to be root of 144, which is 12. And given that P is the point on the circle that is nearest to origin O, find the exact length of OP. So let's draw a rough sketch of the circle first. Center is -4 and 7, so this is your center. So this is the circle, let's say. We have to find the length of OP. Since the radius is 144, so this is your radius. Okay, this is R. And OP is basically the distance from point O to P. So if this is our O point, this is O, and we're saying this is P. This is OP. So to find the distance of OP, what we're going to do is we're going to subtract OC from the radius. Why OC? Because OP lies on the circumference. And the question has clearly said that given that P is the point in the circle that is nearest to the origin. So nearest to the origin means it's going to be somewhere over here. And radius is the distance from the center of the circle towards the circumference of the circle, like the boundary. So if this is OP, this is C. So if we find OC, we can subtract that from R and that will give us OP. So OC is going to be -4 squared plus 7 squared. Is going to give us a value of root 65. So OP is going to be R minus OC. R is 12 minus root 65. And that's the exact value of OP. And the question also said that find the exact length of OP. So you leave it as it is. You cannot further solve it. You don't need to convert it into decimals because it says exact length. So that's your answer. Then find the first four terms in ascending powers of x, the binomial expansion of 3 plus 2x whole power 6, giving each coefficient in simplest form. So for this part, we're going to expand 3 plus 2x to the power of 6, but just for the first four terms. That's going to be 6c0 times 3 to the power of 6 times 2x to the power of 0 plus 6c1 times 3 to the power of 5 times 2x to the power of 1 plus 6c2 times 3 to the power of 4 times 2x to the power of 2 plus 6c3 times 3 to the power of 3 times 2x to the power of 3. So these are the first four terms. So that gives us a value of 729 plus 2916x, then plus 4860x squared, and then plus 4320x cubed. These are the first four terms. Simple as that. For this, you just need to remember the binomial expansion. Put the values, the a value, the b value, the n value, and the r value. N is 6. R is going to be 0, 1, 2, and 3. A is 3. B is 2x. Put in the expansion formula and then just solve in the calculator. Then it says, hence find the coefficient of x squared in the expansion of 2x squared minus 1 over 6x times 3 plus 2x to the power of 6. So that's going to be 2 x squared minus 1 over 6x. And over here for the expansion, we're just talking about the terms with x squared. So that means 2x squared times 729. And then 1 over 6x times 4320 x cube. These are the two terms we'll be using for the expansion, because multiplying these two with other terms will not give us x squared. So 2x squared times 729 minus 1 over 6x times 4320 x cube, which gives us a value of 1458x squared minus 720x squared, which equals to 738x squared. That's the term with x squared. Then it says, in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So the depth of water d meters in a harbor on a particular day is given by the equation d equals to 8 plus 5 sine pi t over 6 plus 3, where t is from 0 to 24, where t is the number of hours after midnight. Show that the depth of water in the harbor at 2 m is just over 4 meters. Find to the nearest minute the first time after midday when the depth of water in the harbor is exactly 6 meters. So we'll put t as 2 and then we solve it for d. So d equals to 8 plus 5 sine of pi times 2 over 6. Once again, the question says show that the depth of water in the harbor at 2 m is just over 4 meters. So when you put 2 as t, we should get a value for d which is more than 4. So 8 plus 5 sine of pi by 3 plus 3, and that gives us a value of 4.07, which is over 4 meters. So that's your answer. Then find to the nearest minute, the first time after midday when the depth of water in the harbor is exactly 6 meters. So you put d as 6 and find the value of t. So 6 equals to 8 plus 5 sine pi t over 6 plus 3. 6 minus 8 over 5 equals to sine of pi t over 6 plus 3. That's going to give us a value of negative 0.4, which is sine of pi t over 6 plus 3. So then we do sine inverse of negative 0.4 equals to pi t over 6 plus 3. So that's going to be negative 0.41 equals to pi t over 6 plus 3. Now you find the value of t. The sign is negative in the third quadrant and the fourth quadrant. So that's going to be 0.41 over here and 0.41 over here. So it's going to be pi plus 0.41 and 2 pi minus 0.41. That equals to pi t over 6 plus 3. That's 3.55. And the other one is going to be 5.87. So we minus 3 and then times by 6 and divide by pi. So it's going to be like this. 3.55 minus 3 times by 6 over pi. This will be 5.87 minus 3 times by 6 divided by pi. That equals to t. So that's 1.05. And the other one is going to be 5.48 equals to t. Now the question said that find to the nearest minute the first time after midday when the depth of water in the harbor is exactly 6 meters. So first time is going to be this 1.05. So after midday, it's going to be 1 hour and 5 minutes. For the time, it's going to be 1:03 p.m. because the value we got over here is 1.05. So the 0.05 times 60 is 3 minutes. It's 1.05. So the 1 hour that gets added to 12, so that becomes 1 p.m. and then plus 3. So 1 hour and 3 minutes. That's your answer. Then question 6 say there's a function 4x cubed plus px squared plus 8x plus q, where p and q are constants. Given that 2x plus 3 is a factor of f of x has a remainder of -5 and divided by x plus 2. Show that p equals to 10 and find the value of q. So for that, we first put x equals to -3 over 2 in the equation and put f of x equals to 0 because x equals to -3 over 2 is a factor. So if it's a factor, then f of x would be equal to, so if it's a factor, then f of x will be equal to 0. So 0 equals to f of -3 over 2. So that's going to be 0 equals to 4 times -3 over 2 cube plus p times -3 over 2 squared plus 8 times -3 over 2 plus q. That's going to be 0 equals to -27 over 2 plus p times 9 over 4 minus 12 plus q. Now I further simplify this equation, so that's going to be 27 over 2 plus 12 equals to 9p over 4 plus q. Seven times 2 plus 12 times 4 equals to 9p plus 4q, which is going to be 54 plus 48 equals to 9p plus 4q, and that's going to be 102 equals to 9p plus 4q. That's the first equation. Now what we do is we put x equals to -2 in the function, and that gives us a remainder of -5. So next equation is going to be -5 equals to 4 times -2q plus p times -2 squared plus 8 times -2 plus q. That's going to be -5 equals to 4 times -8, which is going to be -32 plus 4p minus 16 plus q. That's going to be -5 plus 32 plus 16 equals to 4p plus q, which is going to be 43 equals to 4p plus q. What I'm going to do is I'm going to make use of the subject in the second equation. So that's going to be 43 minus 4p. That is your third equation. I'm going to sub the third equation in first one. So that's going to be 102 equals to 9p plus 4 times 43 minus 4p. So that's 102 equals to 9p plus 4 times 43 is 172 minus 16p. 102 minus 172 equals to 9p minus 16p, which is going to be negative 70 equals to negative 7p. That's 10 equals to p, which is what the question was asking us to prove as well. Then the question is saying that we need to find the value of q. So to find the value of q, we can just put it back into the third equation where q was 43 minus 4p. That's 43 minus 4 times 10. And that gives us a value of 3 for q. That's your answer. Then, hence find the range of values of x for which f of x is decreasing. Solutions based entirely on calculator technology are not acceptable. So if it's decreasing, that means first we differentiate the function. F of x is going to be 4x cubed plus 10x squared because p is 10 plus 8x plus 3 because q is 3. Differentiate this, bring the power down, multiply it with the coefficient, then subtract 1 from the power. So 12x squared plus 20x plus 8. So they're saying that the function is decreasing, which means we put it equal to 0. And that's going to be 0 equals to 12x squared plus 20x plus 8. Now, I'm going to factorize this quadratic equation so we can simplify it first. Divide everything by 4. That's going to be 3x squared plus 5x plus 2. So when you factorize this, what we get is 3x squared plus 3x plus 2x plus 2, 3x bracket x plus 1, and then plus 2 bracket x plus 1. That's going to be x plus 1 bracket 3x plus 2. So one value of x is negative 1. Other is negative 2 over 3. So negative 1 and negative 2 over 3. So these are your turning points basically, because when I put the derivative equal to 0, that gives us the stationary points, and stationary points are the turning points. So negative 2 over 3 is going to be over here, negative 1 is going to be over here. So that means it's going to be something like this, let's say. So this said, find the values of x where the function is decreasing. Yeah, the range of values of x for its function is decreasing. So we can see that the function is decreasing in this part, over here and over here. So in this region from negative 1 to negative 2 over 3. So the function is decreasing when x is less than -2/3 and when it's greater than -1. That's when the function is decreasing. That's your answer. Then it says solve for x is from 0 to 2 pi, the equation 3 sine x tan x equals to 11 plus cos x, giving the answers in radians to 3 decimal places. So for that, what we're going to do is, first we're going to begin with replacing tan x with sine x over cos x. So sine x over cos x equals to 11 plus cos x. Multiply it, it's going to be 3 sine square x over cos x equals to 11 plus cos x. So replace the sine square x with 1 minus cos square x because I want everything to be in terms of cos to solve it. And then we can cross multiply the cos x with 11 plus cos x. So that's 3 minus 3 cos square x equals to 11 cos x plus cos square x. So bring everything to the right hand side. So it's going to be 4 cos square x plus 11 cos x, and then it's going to be minus 3. So now we factorize this quadratic equation. So 4 times 3 is 12, and we can use the factors of 12 and 1. So 4 cos square x plus 12 cos x minus cos x minus 3. So you have 4 cos x times cos x plus 3 minus 1, and then cos x plus 3. So we have cos x plus 3 times 4 cos x minus 1. So cos x plus 3 equals to 0, and 4 cos x minus 1 equals to 0. Cos x equals to -3. Cos x equals to 1 over 4. So cos inverse of -3 is not applicable, so I'm not going to do that. But we can find cos inverse of -1 over 4, and that gives us a value of 1.318 in radians, and we get 4.965. These are the two angles. Correct to 3 decimal places. Then given that theta is from 0 to 90 degrees and cos theta equals to 1 over 3. Find in simplest form the exact value of tan theta. Okay, so for this, we know that cos theta is equal to 1 over 3. Need to find the value of tan theta. Now we know the identity that 1 equals to cos square theta plus sine square theta. Let's use this identity to figure out the value of sine theta first. So 1 equals to 1 over 3 whole square plus sine square theta. That's 1 equals to 1 over 9 plus sine square theta. So 1 minus 1 over 9 equals to sine square theta. That's going to be 8 over 9, and we square root that, and that equals to sine theta. Now this theta is from 0 to 90, so which means we're going to use only the positive value. And if you want, you can even simplify the square root of 8 over 9 to, if you want, you can even simplify square root 8 over 9 to 2 root 2 over 3. So then tan theta is going to be sine theta over cos theta, which is going to be 2 root 2 over 3 divided by 1 over 3. It's going to give us a value of 2 root 2. That is the exact value of tan theta. Then it says in an arithmetic series, the first term is a and the common difference is d. Show that the sum of n terms is equals to n over 2 times 2a plus n minus 1 times d. So now to prove that the sum of n terms is equal to this, what we're going to do is firstly, we need to know that when we find the sum of n terms, first term is a. Now second term is going to be a plus the common difference. Next term is going to be a plus 2d plus so on. And then our last term is going to be a plus n minus 1 times d, which is basically your nth term. Before that, what you can get is a plus n minus 2d. So this is the term before a plus n minus 1 times d. So if I rewrite this, that's going to be a plus n minus 2 times d plus a plus n minus 1 times d. Now what I'm going to do is I'm going to make another equation for sum of n terms, but now I'm going to start in the opposite order. I'm going to say that the first term is a plus n minus 1 times d. Then the next term is going to be a plus n minus 2 times d, and so on. And then at the end, we have a plus d, and then plus a. So this is your first equation. This is your second equation. Once you've created these two equations, and both of them are basically representing the same thing, it's sum of the n terms. In the first equation, I'm starting with a, then I'm doing a plus d, a plus 2d, and so on. Whereas in the other one, I'm going in the opposite direction. I'm starting with the last term. So in the first one, I'm starting with the first term going towards the nth term. In the second equation, I'm starting with the nth term and going to the first term in backwards order. So if I add the first equation and the second equation, so that's going to be Sn plus Sn on the left-hand side. On the right-hand side, if I add a to a plus n minus 1 times d, that's going to be 2a plus n minus 1 times d. Then if I add a plus d to a plus n minus 2d, let's see what we get over here. So plus a plus d plus a plus n minus 2 times d, and then over here I'm going to add the last two terms to each other. So then it's going to be a plus n minus 2d. So plus, so it's going to be a plus n minus 2 times d, which will be added to again a plus d, and then it's going to be a plus n minus 1 times d. I'm going to add that to a. So now if you notice, Sn plus Sn is 2Sn, and 2a plus n minus 1 times d is going to come as it is. And then a plus a is again 2a. It's going to be dn minus 2d. So if we combine this, it's going to be again So if I multiply n with d and -2 with d, and -2 with d, that's going to be nd minus 2d. And d minus 2d is again minus d. So it's again going to give us plus n minus 1 times d. And same thing over here, a plus n minus 2 times d plus a plus d, which is same as this one. It's going to give us again the same thing. So plus 2a plus n minus 1 times d, and again plus 2a plus n minus 1 times d. So if you notice, on the right hand side, we're adding the same term to each other, 2a plus n minus 1 times d plus 2a plus n minus 1 times d. So n number of times the same term is added to each other. So it's going to be 2sn equals to n times 2a plus n minus 1 times d. So Sn is going to be n over 2 times 2a plus n minus 1 times d. So that's your expression for the sum of n terms as asked us to prove in the question. Then says hence find 900 plus 892 plus 884 plus so on till plus 500. So what I'm going to do is, in this case, I'm going to find the first term, the common difference, and the n value, and then I'm going to put it in the formula to find the value of the to find the sum of the given terms. So as we know, a is the first term, which is 900, and d is going to be the difference between two consecutive terms. So a is going to be 900. Common difference is going to be 892 minus 900, which gives us a value of -8. Now for the nth term, we know that the last term was given as 500. So 500 is basically equal to a plus n minus 1 times d. So a is 900, n is what we're trying to find, and d is -8. So 500 minus 900 divided by -8 plus 1 equals to n. That gives us a value of 51. So that's n. So now we're going to put these in the sum of n terms formula. So we have to find the sum of first 51 terms. So it's going to be 51 divided by 2 times 900 plus 51 minus 1 times -8. That gives us a value of 35,700. That's the sum of the first 51 terms. So it says, given that the first three terms of a geometric series are k plus 4, k minus 2, and 11 minus k, where k is a constant, show that 2k squared minus 11k minus 40 equals to 0. Then given also that the series is convergent, find the value of s. Find the value of sum to infinity. So we have k plus 4, k minus 2, and then 11 minus k. Since it's a geometric sequence, the common ratio is going to be the fraction made from two consecutive numbers, so k minus 2 over k plus 4, and similarly 11 minus k over k minus 2. So both represent the same thing, which is the common ratio. So k minus 2 over k plus 4 is the same as 11 minus k over k minus 2. Now we cross multiply. It's going to be k minus 2 whole square equals to 11 minus k times k plus 4. Expand the bracket. That's going to be k square minus 4k and then plus 4 equals to 11k plus 44 minus k square and then minus 4k. So bring all of the terms on one side. So it's going to be k squared plus k squared minus 4k plus 4k minus 11k plus 4 minus 44 equals to 0. That's 2k squared minus 11k and then minus 40 equals to 0. That is the equation that was given the question as well. Then given that this series is convergent, find the value of sum to infinity. So for that, we have to figure out the value of k first, because without that, we can't figure out the common ratio or the first term. So in that case, we factorize the quadratic equation, 2k squared minus 11k, and then minus 40 equals to 0. 2 times 40 is 80. Factors of 80 that we can use to replace 11 is 16 and 5. 2k squared minus 16k plus 5k minus 40 equals to 0. 2k bracket k minus 8 plus 5 bracket k minus 8 equals to 0. K minus 8 bracket 2k plus 5 equals to 0. K equals to 8 and k equals to negative 5 over 2. For the a value, it's going to be 8 plus 4, which is going to give us 12. And if we use k equals to 8, that gives us a equals to 12, and r is going to be 8 minus 2 over 8 plus 4, which gives us a value of 1 over 2. If I use k equals to negative 5 over 2, a is going to be negative 5 over 2 plus 4, which gives us a value of 3 over 2. So that gives us a value of negative 9 over 2 divided by 3 over 2, which simplifies to negative 3. So if we use k equals to 8, we're getting a equals to 12 and r equals to 1 over 2. If we use k equals to negative 5 over 2, getting a equals to 3 over 2 and r is negative 3. So if I find the sum to infinity using the first set of values, it's going to be 12 over 1 minus 1 over 2, which gives us a value of 24. And if I use the second set of values, that's 3 over 2 divided by 1 minus negative 3. That gives me a value of, that's going to give us 0.375. Now, when a series is convergent, you should know that your R value can only be between positive 1 and negative 1. Over here, this value is out of the range, which means we can't use a equals to 3 over 2 and r equals to negative 3. We can only stick to this one, where a is 12 and r is 1 over 2, which is within the range. So this is correct, this is incorrect. That's how you solve this. It says given that 3 log to the base of 2 of t plus 4 minus 2 log t minus 2 to the base of 2 equals to 7. Verify that t equals to 4 is the solution of the above equation. So to verify that, what we're going to do is we're going to substitute t equals to 4 in the equation and see if it gives us a value of 7. So 3 log base 2 times 4 plus 4 minus 2 log 4 minus 2 equals to 7. 3 log base 2, 8 minus 2 log base 2, 2 equals to 7. Log 2 to the base of 2 equals to 1. And over here, can you write 8 as 2 cube? So this is 2 times 1. Bring the 3 down, so it becomes 3 times 3 times log 2 to the base of 2 minus 2 equals to 7. Again, log 2 to the base of 2 is 1, so it's 9 minus 2. And as you can see, it equals to 7 as it already does in the question. So yes, it is correct. Then show that t cube minus 116 t square plus 560 t minus 448 equals to 0. So for this, we have to rewrite the log equation as a polynomial. So in that case, our log is log 2 times t plus 4. Now I'm bringing the coefficient up in the power over here. And over here, again, I brought the coefficient up in the power. So again, log base 2 times t minus 2, and I brought the coefficient up in the power again, equals to 7. And I'm going to attach a log with 7, which is going to be log 2 to the base of 2. If it's a constant, you can always multiply it with a log, keeping in mind that the number and the base are the same. So now when two logs with the same base are being subtracted, we can divide the number. So it's going to be log to the base of 2 with t plus 4 whole cube divided by t minus 2 squared equals to log of 2 to the power of 7 base 2. The two logs get cancelled out and we're left with t plus 4 whole cube divided by t minus 2 squared equals to 2 to the power of 7. Now we're going to expand the brackets. So the t plus 4 whole cube, we can either use the cubic expansion or you can just split it into t plus 4 times t plus 4 whole square and then expand it. So if we do that, t plus 4 times t plus 4 cube equals to 2 to the power of 7 is 128. So 128 times t minus 2 squared. So t plus 4, this is square, not cube. That's t squared plus 8t plus 16 equals to 128 times t squared minus 4t plus 4. Now we expand the bracket again, so it's going to be t cubed plus 8t squared plus 16t plus 4t squared plus 32t plus 16 times 4, which is going to be 64, equals to 128 t squared minus 512t, and then that's going to be minus 448. Now we're going to bring everything on one side and then combine the like terms. So t cubed minus 116 t squared plus 560 t minus 448 equals to 0. So if you go back to the question, this is exactly what they wanted us to prove. Now, hence using algebra and showing your working, solve the logarithmic equation. Solve the logarithmic equation, giving each answer in simplest form. Solutions based entirely on calculated technology are not acceptable. So to find the value of t, we're going to use the polynomial that we just found in the previous part. Now, if we remember in the question, it mentions that t equals to 4 is a solution of the above equation, which means t equals to 4 is also a solution of the polynomial that we've created. So which means if we divide this by t minus 4, we can further factorize this. So t cubed minus 116 t squared plus 560 minus 448. So t squared times t is t cubed. T squared times negative 4 is negative 4 t squared. Change the signs. It's positive, we make it negative. It's negative, we make it positive. So t cubed minus t cubed is 0. Negative 116 t squared plus 4 t squared is going to be negative 112 t squared. Then plus 560 t comes down, and so does negative 448. Now we times t by 100 and negative 112 t, which is going to be negative 112 t squared, and negative 112 t times negative 4 is going to give me negative 448 t. Negative 448 t. Subtract them. Change the signs. Positive, positive. So this becomes 0. 560 minus 448 is going to give us 112. So 112 t minus 448. Then again we times it by 112. So plus 112, that's going to be 112 t. It's positive, we make it negative. 112 times 4 is going to be 448. Negative in this case, make it positive. So we minus it and that gives us 0. So there's no remainder. So it's t minus 4 times t squared minus 112 t plus 112. Now I'm going to factorize this quadratic equation because they want all of the solutions. So for this, I'm going to use the quadratic formula because numbers are very big. So minus negative 112 plus minus root of negative 112 squared minus 4 times 1 times 112 divided by 2 times 1. That's going to give us a value of 112 plus minus 24 root of 21 over 2, which gives us a value of 56 plus minus 12 root 21. So your other two solutions are t equals to 56 plus 12 root 21, t equals to 56 minus 12 root 21, and then we have t equals to 4. According to the question, since we're dealing with logs, we cannot use the negative solutions. So the solutions that are acceptable over here are going to be this one, and this one. That's it. These are the two acceptable solutions. The reason why we cannot use 56 minus 12 root 21 is because if we convert this into decimals, that's 1.01. And if we go back to the equation, 1.01 minus 2 is going to be negative, and log of a negative number is not possible. Hence, the only two solutions are going to be t equals to 4 and t equals to 56 plus 12 root 21. That's your answer. Then the next question says, in this question, you must show all stages of your working. Solutions aligned in Tyler and calculator technology are not acceptable. Figure 1 shows a sketch of part of the curve C with equation y equals to 9x minus x squared over 2 root x, where x is greater than 0. The point P is the stationary point on C. Find using calculus the x coordinate of point, the x coordinate of P. So for that, we just differentiate the equation, put it equal to 0, and find the x value of P. So what we'll do is y is equal to 9x minus x squared over 2 root x. Simplify this, split into two fractions, 9x over 2 root x and minus x squared over 2 root x. That becomes 9 times x root x over 2, and it's going to be minus 1 over 2 x to the power of 3 over 2. Now we're going to differentiate this. So dy by dx is going to be 1 over 2 times 9 over 2 times x to the power of 1 over 2 minus 1 over 2 times 3 over 2 times x to the power of 3 over 2 minus 1. That gives us a value of 9 over 4 times x to the power of negative 1 over 2 minus 3 over 4 times x to the power of 1 over 2. Now we put this equation equal to 0. So root x over here minus 3 over 4 root x. Make the denominator same, so it's going to be 4 root x 9 minus 3 times root x whole square. 0 equals to 9 minus 3x. 3x equals to 9 and x is 3. So that's your x coordinate of P. Then the finite region R shown in figure 1 is bounded by the curve C, the x-axis, and the line of the equation x equals to 1. Using calculus, calculate the exact area of R. So for that, we need to find this value of x because it's bounded from x equals to 1 to this. And to find the x value of this, you put the equation of the curve equal to 0 to find the x-intercept. So for that, y equals to 0 first. So 0 equals to 9x minus x squared over 2 root x. 0 equals to 9x minus x squared. 0 equals to x bracket 9 minus x equals to 0, x equals to 9. So that means it's going to be from 1 to 9. Now I'm going to write it as a separate fraction, 9x over 2 root x minus x squared over 2 root x dx. Now I'm going to simplify it like I did previously. So the simplified version was 9 over 2 times root x minus 1 over 2 times x to the power of 3 over 2, and then dx. Now we integrate this. So for the first one, we're going to add 1 to the power divided by the new power, which is 3 over 2. And then again, add 1 to the power divided by the new power, which is going to be 5 over 2. From the limit of 1 to 9. So that's going to be simplified to 3x to the power of 3 over 2 from 1 to 9, and then 1 over 5 times x to the power of 5 over 2 from 1 to 9. 3 times 9 to the power of 3 over 2 minus 3 times 1 to the power of 3 over 2 minus 1 over 5 times 9 to the power of 5 over 2 plus 1 over 5 times 1 to the power of 5 over 2. That gives us, so 9 is 3 squares, so it's going to be 3 cubed, which is 27 times 3, 81, minus 3. Again, 3 squares, so 3 to the power of 5, which is given as 243. So 243 over 5 plus 1 over 5. 81 minus 3 is going to be 78 minus 242 over 5, which gives us a value of 148 over 5. That is the exact area of the given shaded region. And with that, we're done with paper 2. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist.